This is Chemistry Made Simple YouTube channel. Let me take this opportunity to welcome you to another great learning segment. Today we concern ourselves with the specific nomenclature of polysubstituted alkanes. First and foremost, we need to understand what it means, polysubstituted alkanes. Polysubstituted alkanes are alkanes that have two or more than two substituents attached to their carbon-carbon chain. For matters of clarity and simplicity, we shall concern ourselves with polyalkyl substituted alkanes. Ladies and gentlemen, how do we name polyalkyl substituted alkanes? In order to name polyalkyl substituted alkanes, we follow guidelines from Iupac as follows. Guideline number 1 is that we must obtain the parent chain. Now, the explanation of what it means by a parent chain we have already seen as the carbon-carbon chain in the compound that has the highest number of carbon atoms. To illustrate the first guideline, consider the compound displayed beside here that has two different alkyl substituents, and therefore the parent chain that will be considered in this case is the one displayed in yellow highlight. As I have said in practice, always transverse the given compound and obtain all the possible carbon-carbon chains and count the total number of carbon atoms in each of the obtained carbon-carbon chains. Then the one with the highest number is your carbon-carbon parent chain. According to Iupac, the second guideline is that assign numbers to the parent carbon chain from the start of the carbon chain to the end of the carbon chain, and from the end of the carbon chain to the start of the carbon chain. Still, by basing on the displayed compound in rule number 1, this procedure is done as shown here. Realize that we have numbered the carbon atoms in the parent chain from the beginning of the chain to the end of the chain, and from the end of the chain until the beginning of the chain. At this point, we compute the lowest locant sum. We need to first and foremost understand what it means by locant by referring to the illustration used in guideline number 2. The numbers 3 and 4 and the numbers 5 and 4 as displayed there give the position of the methyl group and the ethyl group along the parent carbon chain, and therefore each of the numbers there is known as a locant, simply because it helps us to locate the position of a substituent along the parent carbon chain. Therefore, the sum of those different pairs of numbers is as displayed there, 7 and 9. And of course, the lowest is 7. Ladies and gentlemen, guideline number 4. At this step, we are now able to write down the name of our compound by just following two simple procedures. The first procedure is that consider the lowest sum of locants. Secondly, different alkyl substituents must be written in order of their alphabetical superiority, and presence of similar alkyl substituents must be indicated by using the prefixes di for 2 similar alkyl substituents, tri for 3 similar alkyl substituents, tetra for 4 similar alkyl substituents, penta for 5 similar alkyl substituents, and so on, as derived from Latin. At this step, we can therefore write down the name of the compound that we have been using for illustration since guideline number 1 as 4-ethyl 3-methyl heptane. For further illustration and clarity, let us have another compound which we are going to name. Look at the compound displayed here besides. According to the first guideline, we determine the parent chain. Now, the carbon chain that has been circled in red is our parent chain, and therefore, the parent name of our compound is going to be pentane. Next, we assign number to carbon atoms on the parent chain from the start of the chain until the end of the chain, and from the end of the chain until the start of the chain, as displayed there. And therefore, the sum of alkanes is as displayed there. Of course, the lowest sum is 5. Finally, we can now write the name of the compound. Since they are similar alkyl substituents, the name of the compound there becomes 2, 3 hyphen dimethyl pentane. At this step, I will come into the classroom where we shall actively write down the name of one or two displayed compounds. Ladies and gentlemen, welcome to the classroom. And with us, we have a question where we're supposed to name this compound systematically. Systematically just implies that we must follow the guidelines. Now, by basing on the guidelines is that number one, we must identify the parent chain. As I have said above, is that the parent chain is always the longest carbon-carbon skeleton in the compound. Always make it an effort to transverse through the compound to obtain all the possible carbon-carbon connections. And from those carbon-carbon connections, choose the longest. And therefore, without wasting time, the longest or parent chain for that case, therefore, is this that I am encircling in red for our compound today. This is our parent chain, which, by the way, has a total of 1, 2, 3, 4, 5, 6, 7, 8. It has 8 carbon atoms, and this goes without hesitation that the parent name is octane. Now, after identifying the parent chain, and for that case the parent name, we proceed according to the second guideline and assign numbers from the start of the chain to the end of the chain, and from the end of the chain backwards until the start of the chain, which I'm going to do as follows. So the numbers are 1, 2, 3, 4, 5, 6, 7, 8. And coming backwards is 1, this is 2, 3, 4, 5, 6, 7, and finally 8. Now, the numbers that we have obtained there, they were numbers of specific or special consideration, is the number 4. Why? Because the number 4 has a substituent, and we also have the number 6, which has a substituent on it. And going that side, we are having the number 3, which has a substituent, and going that direction also, we have the number 5. By the way, the substituents that there are in these compounds are this one here, which we can agree that is known as the methyl group, and this one here, which we said is either secondary propyl, or for that case isopropyl. So any of those two will work for the two substituents. After doing this, so we are going to compute now the sum of substituents, and from that we have 3 summed up with 5 for those who are going that direction, and this gives us the sum of 8. And then coming backwards, we have 4 summed up with 6, which gives us 10. Now from these two sums we choose the lowest, and this is the lowest, so this is the one which we are going to be using. Since we are having two different alkyl substituents, we therefore write down the name of our compound by basing on their alphabetical arrangement as follows. Since we are using this, on position 5 we have an isopropyl group, and then on position 3 we have a methyl group, and finally our parent name. What is the parent name? The parent name is octane. So this is one name for someone who has used isopropyl. We could also use secondary propyl, and our name is also written as 3-methyl, followed by a hyphen, another hyphen, and then secondary propyl, and our parent name octane. Both names are correct since they have fully certified the above guidelines, and also they have been written in alphabetical arrangement of the different alkyl substituents. So if I will just encircle them in red, the name of our compound is as simple as that. Part B here, we are also supposed to identify the correct name of the compound by following the guidelines above. Guideline number 1 requires us to determine the parent chain, and without wasting time, this in red is our parent chain, but I have to insist that before you determine the parent chain, you must go through the compound and identify all the possible carbon-carbon connections, and from the carbon-carbon connections that you have identified, the parent chain is always the carbon-carbon connection that has the highest number. By the way, our parent chain has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon atoms, and therefore the parent name, for that case name, is going to be, since it is having 9 carbon atoms. The second guideline is that we are supposed to assign numbers to carbon atoms on the parent chain from the start to the end of the chain, and from the end of the chain to the start of the chain, which we do as follows. This is number 1, number 2, number 3, number 4, number 5, 6, 7, 8, and 9. Then coming backwards, this is number 1, number 2, 3, 4, 5, 6, 7, 8, 9. Now from the numbers that we have assigned there, the numbers of consideration are 3, then also 7, and then we shall have 5, and in that case also 5, and there is 4 and 6, and finally 8 and These numbers are locants because they give us the position of the substituents that are on our parent chain. And we continue and compute the sum of the numbers there. So to sum them up, we shall have 3 summed up with 5, summed up with 6, and finally summed up with 8. And for that person coming from that side, that is 2 summed up with 4, summed up with 5 for this, and finally summed up with 7. So the sum of this is 8 plus 6, giving us 14, plus 8, giving us a sum of 22. And this is 6 plus 5, 11, plus 7, giving us a sum of 18. And of course, the guideline says we must use the lowest sum. And this is the lowest sum. So these numbers that have encircled are the ones that will help us to write the name of our compound. At this step, we have to remind ourselves that the substituents which we have are this one here, which you remember that we called cyclobutyl, then this, and this are of the same kind, and each of them is known as ethyl. Finally, this, which we also called an ethyl group or simply ethyl. So by considering their alphabetical arrangement and these numbers here, therefore write the name of our compound as 7 cyclobutyl followed by 4 ethyl followed by, now on position 2, position 5, and position 7 we have methyl groups, so we write all of them 2, 5, 7, and then a hyphen. Because they are 3, we use the prefix tri to indicate that they are 3, and then the name of each of them is followed by our parent name. The parent name we obtained there is as simple as that. For matters of emphasis, I circle it in red. Ladies and gentlemen, I take this opportunity to thank you for being part of my presentation. Do you have any challenging concept as regards organic chemistry? Please contact me by email using the email address in the description of this video, and I will gladly get back to you. Until next time, I remain yours truly, your chemistry teacher. Goodbye for now.